Welcome to a journey guided by history's greatest minds. 1 year to master calculus. Let's begin.
What's up, everybody? Welcome to 1 year calculus week 12. This week we are asked to find the area between two curves. What are those two curves that I was given? The first curve that I was given was cos x, second curve that I was given was cos square x. I had to draw this beforehand because I'm not really good at drawing. So if I decided to draw this while recording, I'll waste a lot of time. But yes, this is supposed to be what it's supposed to look like. But I know it's not great, but yes, this is our curve for cos x, and this is our curve for cos square x. And so we should find the area between them at this point. Now, I'm not really sure if this is the only part that is between cos x and cos square x. That it's possible that a function can be like this, then the second function can be like this. So you can see that they intersect in multiple places. But this particular question says we should only find where they intersect in only one part. It's supposed that they intersect in many other places, but they only restricted us between here and here. So our definite integral is not going to be from positive infinity to negative infinity. We are restricted between a boundary. That's when x is equal to pi over 2 and when x is equal to 0. So that's basically the first part of what we need. The second part of what we need to find out is to set up a definite integral to find. That is how we find most of the areas in calculus. So now if you want to find the definite integral of cos x, you are basically finding the area under the graph of cos x to the x-axis. So if I find the area under the cos x, let's say the integral of cos x. If I find the area under cos x, I want to find the area between cos x and cos square x. Then you subtract the definite integral of cos square x. Are you understand what I'm saying? You want to find the area between cos x and cos square x. The definite integral shows you the area under cos x to the x-axis. The definite integral of cos square x shows you the area under the cos square x curve to the x-axis. So if you want to find the area between them, then that area is basically the area under the cos x, then subtract the area under cos square x. That's basically how you set up the definite integral. But that's not all. They gave us boundaries. The first boundary, that is the global boundary, is when x is equal to 0. And the upper boundary is when x equals pi over 2. There's no really need for me to put x is equal to 0 when we're already differentiating in terms of x, with respect to x. We're already differentiating with respect to x. So these are our definite integrals that we have to solve. Let me rewrite it for clarity. We have the definite integral from 0 to pi over 2 of cos x dx minus the definite integral from 0 to pi over 2 of cos square x dx. So this is basically the definite integral that I have to solve. And what's the difference between definite integral and indefinite integral? Well, they are basically the same thing, just that definite integral have an upper limit and a lower limit. They are the same thing in the sense that the integral of x with respect to x is going to give you a particular value. The definite integral of x with respect to x is going to give you that same value. Let us say you want to integrate x with respect to x, you are going to get x squared divided by 2. If you are finding the definite integral of x with respect to x, you are still going to get x squared divided by 2. Just like in this case, you are going to plug in your upper limit, then subtract your lower limit. But it's the same, same algebraic function that you are going to get after integrating. I don't know if that makes sense. So that you go one step further for definite integral by plugging your upper value and your lower limit. Okay, so since we have given the basics of definite integral, and we have already determined the integral that we're going to use to find the area between these two functions, then let's basically solve. Let's call this area A1, and let's call this area A2. Then what we're looking for is the difference of those areas, which is equal to A1 minus A2. Now, in case you're confused, let us say I don't give you this graph. I already told you cos x and cos square x. Then you'll be wondering which one is greater, which one is lesser. You are not going to be sure. Is cos square x above cos x, or is cos x above cos square x? Well, that's why most of the time, whenever you're solving definite integrals between curves, they usually just use absolute value. So this absolute value means that even if you have a1 minus a2 or a2 minus a1, you still get the same answer, because the positive will change to positive and negative will change to positive. the positive remain the same and negative will change to positive. So now you have the difference of, or the area that we're looking for is equal to the absolute value of the difference of a1 minus a2. Okay, but in this case you don't really need the absolute value because I've already shown the graph, so we already know that cos x is greater than cos square x, so there's no really need for the absolute value. But we just write a1 minus a2. So we write a1 minus a2. Well, let's begin to solve basically. I will write this up here for space. So now what is a1 and what is a2? a1 is equal to the definite integral from 0 to pi over 2 of cos x dx. Now what's the integral of cos x with respect to x? The integral of cos x is equal to sin x, because the derivative of sin x is equal to cos x, so the integral of, or the antiderivative of cos x will equal to sin x. I know most of you will be like, what? It's not just sin x, it's sin x plus c. But I'm going to tell you the reason why we're not going to have plus c. But let's finish solving, and I'll show you the reason why there's no need for plus c. So now, remember we have upper limit and lower limit. The lower limit is 0 and the upper limit is pi over 2. So now if you plug in pi over 2 into sin x, remember that pi is equal to 180 degrees for those of you in Nigeria that you are using degrees instead of radians. Then pi over 2 is going to equal to 180 degrees divided by 2. 180 degrees divided by 2 is equal to 90 degrees. So sin 90 is what? Sin 90 is equal to 1. So this here is equal to 1 plus c minus, then plug in 0. By then you plug in sin 0. Sin 0 is equal to what? 0. 0 radians equal to 0 degrees. So sin 0 degrees plus c is going to equal to 0 plus c, which is equal to c. So you have 1 plus c minus c. So you have 1 plus c minus c. So these c's will cancel out. So you just have a1 is equal to 1. That is the reason why you don't need to add plus c when you're finding definite integrals. Because even if you add plus c or not, when you're finding definite integrals, they will still cancel out. So there's no really need for you to add plus c or plus whatever. As long as it's constant, they will end up cancelling out when you're finding the definite integrals. So in this case, I'll show you why there's no need for plus c. But just in case at the time that I have not reached this stage and you are still adding plus c to all your integrals, just like definite integrals, you don't really need to add plus c to it. So our answer for a1 is equal to 1. So we don't really need any of this anymore. So you have a1 is equal to 1. Now let's find what a2 is. Remember what we're looking for is a1 minus a2. That's our answer. So I found what a1 is. a1 is 1 unit squared. They don't tell us if this is centimeters or degrees or anything, so you just put 1 unit squared. Okay. Now this a2 now is equal to, I think I will need space, so I will just clean most of these functions, but this is a more complex one. It's cos square x and not just cos x, it's more complex. So I'll clean most of this here. So you have a2 is equal to this definite integral. We have the definite integral from 0 to pi over 2 of cos square x with respect to x. So this is equal to what? This is equal to, no, before we reach this stage, I want to tell you an identity that will simplify cos square x. Let's start from this identity. What's the identity for cos a plus b? This is a known identity, is equal to cos a times cos b minus sin a times sin b. Now what if a is equal to b? If a is equal to b, then you have cos a plus a, and this is equal to what? Cos 2a, and this will be equal to cos a times cos a minus sin a times sin a. Cos a times cos a is equal to something. Cos a times cos a is equal to cos square a, and negative sin a times sin a is equal to negative sin square a. Negative sin square a. So what this means is that cos 2a is equal to cos square a minus sin square a. This is the identity we are going to use to solve this. Before we use it, let's simplify it a little. Consider we have cos square a. If you put this inside here, then you end up having sin square a in your integral. We want to get rid of all these squares. We want to just make it linear. So now this sine square is equal to something. Remember that sine square A is equal to 1 minus cos square A. So we're going to put this into our function. What this means is that cos 2A is equal to cos square A minus bracket open 1 minus cos square A. If we simplify again, this means that cos 2A is equal to cos square A minus 1 plus cos square A. Cos square A minus 1 plus cos square A is same thing as 2 cos square A minus 1. Good. Move minus 1 to the left, to the right hand side. To the left hand side, you have okay, it's clean, small. Okay, we have cos 2A plus 1 is going to equal to 2 cos square A. If we divide both sides by 2, then you have cos square A is going to equal to 1 over 2 times cos 2A plus 1. So this is the next thing we're going to use to solve this integral. We have cos square A is equal to half times cos 2A plus 1. If you put this into the integral, then now we have half, instead of cos square A, we have cos 2A plus 1 with respect to x. Sorry, cos 2x. That was cos square x, so we have cos 2x plus 1 with respect to x. Integrated with respect to x. So now you can separate this. So a2 is equal to half times the definite integral from 0 to pi over 2 of cos 2x dx plus half times the definite integral from 0 to pi over 2 of 1 dx. This is a simpler one to solve, so we're going to solve this one first. So here we have plus half times the definite integral from 0 to pi over 2 of 1 dx. The integral of 1 with respect to x is equal to x. So instead of all this, we'll just have x from 0 to pi over 2. If I integrate from, if we are plugging in your upper limit and your lower limit for x, then here we have pi over 2 minus 0, which is same thing as pi over 2. Pi over 2 times half is just pi over 4. So whatever answer I'm going to get here, we'll just add plus pi over 4. So we don't need any of this anymore. So now we're left with a2 is equal to half times the definite integral from 0 to pi over 2 of cos 2x with respect to x. So here we have cos 2x, but we don't really know how to integrate cos 2x. So what we're going to do here is use substitution. Let u equal to 2x, because we know how to find the integral of cos u, but we don't know how to find the integral of cos 2x. So we say let u equal to 2x. And now we know that the derivative of u is going to be equal to 2 times the derivative of x. What this means is that the x is equal to the u over 2. So if we put that inside here, remember that 2x is equal to u, and the x is equal to the u over 2. And this divided by 2 can go to the front, and we have 1 over 4. So here we have 1 over 4 times of the integral of 0 to pi over 2 of cos u du. The integral of cos u with respect to u is equal to sin u. So all we have here is 1 over 4 sin u from 0 to pi over 2. But remember, we had u is equal to 2x. So instead of sin u, we are going to have sin 2x from 0 to pi over 2. If you plug in your upper limit, you are going to have sin pi. And sin pi is equal to 0. So here is 1 over 4 times 0 minus the lower limit. By the time you plug in 0, you are going to have sin 0. And sin 0 is equal to 0. So you have 1 over 4 times 0 minus 0, which is also equal to 1 over 4 times 0, which is equal to 0. So you have 0. So this part of a2 is equal to 0. So we don't really need any of this anymore. So our total solution for a2 is equal to 0 plus pi over 4. We don't need 0 here, so our a2 is just equal to pi over 4. So remember, we're looking for the area or the difference in those areas, which is equal to a1 minus a2. a1 is equal to 1 unit squared, and a2 is equal to pi over 4 units squared. So what we have here is 1 minus pi over 4 units squared, and this is our answer. Another way to write this answer is 4 minus pi over 4 unit squared. Another way to write it is using approximation. That's you approximate the value. And that's approximately equal to 0.2146 units squared. So these are our 3 possible ways to write the answer. And that brings us end of this week of calculus. We have this integral, or this area between these two curves, is approximately equal to 0.2146 units squared. Thank you for watching this video. I can't wait to see you in the next week's video. Thank you.
Yeah, calculate. Check the variables, running up commas, that's summation. Solve for x, that's a new placement. The logic solid, every